Well, how do you make a great charcoal stove? Um, Actually, we're getting closer and closer to understanding how to do that. And the design principles that Sam and Ryan made were right, and that was about 4 years ago. And we have added some numbers to make them more specific. So here we go. This is a GECO charcoal stove. This is what you'll find in most places everywhere. It's refractory ceramic, but it is heavy. And heavy absorbs the heat that could have gone into the food. So that is why Larry Winiarski wanted to make lightweight refractory ceramic that is at the most 0.7 grams per cubic centimeter, which means that this will float on water. And so SSM makes these combustion chambers, which were originally for rocket stoves. But the great thing is that this is $2.43 in a container, and it comes in a box. So first of all, it's heavy. That's not great. We want it to be light. It'll absorb less heat, which is then available to go into the food. When you look at the internet and you ask AI, you get various answers, but pretty much for sure we know that to burn up the carbon monoxide, you need 760 degrees centigrade. And then there's time too. So you need probably something like 0.2 seconds at 760 C to burn up the CO. Well, how can this stove do that? There's no resonance time, right? You have the charcoal right here, and then the pot goes right here. And so there's not the necessary resonance time, which is why in the new stove, this line is where the charcoal is going. And so at least you have some space that where you're keeping it at 760 C for hopefully 0.2 seconds. And so that's great. And then, like we said, this is floats on water, this sinks in water. And then the other thing is, it's just obvious, but you want to get the heat in the pot, right? So these pot supports here are pretty high. This thing is up in space, and so you know that heat is trying to get in there, whereas the SSM top is a lot shorter. And so what we say is you want something like 6 mm to 7 mm at the perimeter of the pot to force the hot gases to scrape against the surface, and then to get much better, bigger percentage of the heat into the pot. You need some mixing in there for CO and for PM. Now, the great thing about charcoal is, if it's well made, charcoal does not make smoke, but it makes a lot of CO, okay? And so it really helps. And then you need oxygen to burn it up. So 760 C, 0.2 seconds, and enough oxygen so that you can turn the CO into CO2. And so that's why we have all of these secondary air holes. And that helps with mixing, where you want everything to be really well mixed to get the rate of reaction everywhere, and where you're not having little pockets where it doesn't happen and then the CO escapes. So it's charcoal wants a big door for high power. And so look at how big that is. That's the primary air, right? And you need a lot of primary air to make the high power in charcoal. In this stove, is that the right side? So we have 3 1-inch holes that, and then what you do is, when you want low power, you block the primary air and the secondary air. And so that's why if you were gonna remake this stove, you would make it so that it's tight. This much air is too much. It will be going too fast and you'll have more CO. So the firepower and the amount of CO that's made is directly related. Okay, so we want to really have that
tight sealing door for low power.
Yes, tight sealing, and so in this one you're going to block both the secondary air holes and the primary air holes to get the lowest CO and the lowest firepower, and then you can open them up more to adjust it. Okay, and then we're getting there. Bowl shape versus rocket cylinder. And so, Sam, do you think that they know that this is 6 inches in diameter? So this is more of a rocket stove, a T-Lud type, and really helps to top light that charcoal. Because when you top light it, then there's flame on top, and then the gases always have to pass through the flame. And in a bowl, it's harder to do that, right? And there's no residence time. So we have gone for a more cylindrical rocket shape and not a shallow bowl. And then the last thing is that, okay, the cost, the combustion here. So the combustion chamber is $2.43. The grate, which is really nice, Mr. Shen made a very thick cast iron grate, is $1, and this is $2. So you know, you're getting something that is fairly cheap and can be assembled in your country. And the way that you do that is then you want to protect the outside of this, so you can put that anyway, you can put that in here, and then you can pour cement in there, and that protects the outside. And so we did this in Timor-Leste, and SSM can show you all of this. And we just made a new rocket stove, charcoal stove, and T-Lud, and we're going to do a series of these videos to show you how, hopefully, to make something very new and modern, but that can be sold in a market without carbon revenue. So thanks very much.